Okay, so this is 2024 paper 2 question 6 GCE. They decided to make part A bit different and probably much easier. So to solve this, we have, let me use the same paper. We have 3 cos theta plus cot theta is equal to 0. So a lot of students were tempted, of course where theta is limited to this range, a lot of students were tempted to take this one to the other side, write it as cos theta over sine theta, and then cross multiply and then cancel out one cos, which was reducing the number of solutions. So to do this, you can simply write this in terms of sine and cosine. Remember, this is the reciprocal of of tan. The idea here is 1, 2, 3. So the third letter tells you which one this thing represents. For cosec, so you just count 1, 2, 3. So this one is for sine. And then for cot, we already have cot. For sec, you just count 1, 2, 3. So this one is for cos. So in this case, we have the reciprocal for tan, and we know that tan is equal to sine theta over cos theta. So we know this fact. So for us to find cot theta, you just get the reciprocal of this. Remember that cot is the reciprocal of tan. So cot is the same as, instead of having a sine on top, you have the cosine divided by sine theta and equate this to 0. So at this point, you can just factor out the cos. As you can see, we have a cos here and we have a cos there. So you can factor it out and say cos theta. Then in the brackets, you have 3 plus 1 over sine theta. And then everything is equal to 0. And then since when we have two numbers, let's say A and B, the two numbers are multiplying and you're getting a 0 as a product, then this is only possible either when A is equal to 0 or when B is equal to 0, or both numbers are zeros. So to solve for theta, we can take advantage of this. Since we have two numbers multiplying and their product is 0, we can conclude that either cos theta is equal to 0 or 3 plus 1 over sine theta is equal to 0. So if you don't do it like this, or if you decide to divide both sides by cos theta, then you may not get all the possible solutions. So with this one, we know that cos is 0 when theta is equal to 90 degrees. So that means our theta will be 90 and 180, I think. So to do this, you can start with your alpha, because alpha is equal to 0, but this is 0. It's neither positive nor negative. So your alpha will be equal to 90. And because this is equal to 90, it's on the boundary. It's neither in the first quadrant or in the second quadrant. It's right here, 90, and then we have 180 there. Oh, sorry, not this 180 is not okay. So we have 180 and then 270, and then a 0 there. So since we are getting a 0 there, it means cos is on this axis there. It's neither here nor there. It's neither here nor there. It's right there on the axis. So it's 90 or 270. So this is the conclusion you can make. So theta is equal to 90 or 270 degrees. And then you can move on to the other one and solve for theta. So to solve for theta here, you can just take the 3 to the other side. Then I have 1 over sine theta is equal to -3. And then I can, I don't know if flipping will be okay with you, but it's possible you can reciprocate this and this so that you have sine theta is equal to 1 over -3. Or you can cross multiply. Let me use that method which you are more familiar with. You can cross multiply, so this times this will be -3 sine theta is equal to 1, and then divide both sides by -3. So we have sine theta is equal to -1 over 3. So now, as usual, you have to start by finding your alpha. So we can say sine alpha is equal to the modulus of this, which is 1 over 3, so that your alpha is equal to 19.4712. Sorry, I'm not using my calculator, using my laptop. Yeah, so since sine is negative, we know that sine is only negative in the third and fourth quadrant. So in the third quadrant, our theta is equal to 180 plus alpha. And then in the fourth quadrant, our theta is equal to 360 minus alpha. So to find our alpha, we can add this to 180, 19.4712. So this will be 4712, and then a 9, a 9, a 1. So the first one will be this 199.4712. Then the second one will be the difference between 360 and 19.4712. So if I was to put some zeros there, this minus this will be an 8. Then we have a 9 there. This will be an 8. And then another 9 there. This will be whatever, 340.528. So that means our theta is, you write them all down in ascending order. So start with this one, the smallest, followed by the next one, which is 199, rounded off correct to 1 decimal place. Remember, we are dealing with angles in degrees. And then next you have 270 degrees. And then lastly we have 340.5 degrees, and this is your final answer. Then on part B, so on part B we have this. Given that tan theta is equal to n, where theta is an acute angle, find an expression in terms of n for cos theta and then cos 2 theta. So this one was equally a bit different, but easier. So we have this information. We are told that tan theta is equal to n. And then theta is an acute angle, which means it's somewhere between 0 and 90 degrees. I don't know if the boundaries are included, but yeah, it's somewhere in between. So now you can just draw a triangle like this, and then you can call this angle here your theta. I solved this one theoretically in another video. I'll share the link. So, but I think this is the easiest. So to do this, you know that tan theta is equal to this. And then from this shape, remember the last part of SOHCAHTOA, if at all you are still using this, we know that tan theta is equal to opposite over adjacent. So if this is your triangle, then you know that n is the same as n over 1. So you can write tan theta as n over 1. So you can treat this as your opposite. So your opposite will be an n, and then your adjacent will simply be a 1. So once you do this, then you can use the Pythagoras theorem to find the remaining side, and then you can easily find your cos theta. So using the Pythagoras theorem, let's call this triangle ABC. So AB squared is equal to AC squared plus BC squared. And then our AB is unknown. Our AC is 1 squared, still a 1, and then BC squared, that's an n squared. So that means our AB will be the square root of 1 plus n squared. So this will be the square root of 1 plus n squared. So now to find cos theta in terms of n, you can just say cos theta. Referring to this drawing, we know that from SOHCAHTOA to cos theta is equal to the adjacent, this one here, AC, divided by the hypotenuse, which is the longest side of the triangle. So our cos theta here will be AC is 1, and then AB is the square root of 1 plus n squared. And you are done. It was that easy. As long as you understand this, this should be easy. And then part B is saying cos 2 theta, which is probably even easier. So cos 2 theta. With this, you can use the identity, cos 2 theta is equal to cos squared theta minus sine squared theta, or you can make it easier for yourself and use the other version, which has this. That is when you substitute this with 1 minus sine theta. So this will be 2 cos squared theta minus 1. And by the way, both of these identities are provided in paper 2. You'll find them on the cover page. So since we already know what cos theta is, cos theta is simply this thing there. So we can just write, instead of having cos theta, we can write this. In short, we are just substituting this, and then minus 1. And then after this, you can square this. So 1 squared is 1 times 2, we have a 2. Then this denominator squared, you simply have 1 plus n squared. Since the square and the square root will go, then minus 1. And then you can find the common denominator, which is 1 plus n squared. And this into this is 1 times 2, that's a 2. And then you can put a 1 there if you want. 1 into 1 plus n squared is 1 times that. We have 1 plus n squared. So another common mistake here is to leave the brackets out. Remember, this negative is affecting both numbers. So once you leave the brackets out, you are so dead. So you can expand this. We have minus 1 minus n squared over n plus 1 plus n squared. So now 2 minus 1 is 1 minus n squared, everything over n plus n squared, and you are done.